Hello, everyone. Welcome. My name is Florian Pestone. I'm the founder and CEO of InOrbit AI. And today we're going to show this collaboration of 8 companies from around the world. We have 3 continents represented here. And what we're going to show is how robot orchestration allows robots from completely different vendors to work together collaboratively to achieve more complex operations. And if you want to think about why we need orchestration, think about a large company. And maybe you work at one, you're thinking about deploying robots. You have operations around the world across many plants or warehouses. And now in one area, maybe you buy from one local vendor. In another area, you may buy from a different one. And then soon enough, you have multiple vendors. You're thinking about using additional robots for different use cases. So typically, the vendor that sells cleaning robots doesn't sell material handling robots, and conversely. So soon enough, you may end up with like a dozen different brands. And now you have all of these integrations that you need to manage. So that's where you really need orchestration. And orchestration isn't just different robots. It's robots and their environment, both physical and digital. What I mean by digital is you need to have the robots talk to the enterprise systems that know what work needs to be done. So let's work through it. So you're deploying robots around the world. You're trying to figure out where are the robots going to be working. And since we're here at McCormick, we're going to zoom in. We went from that view from space to inside the facility. And this is a map of this area where you're sitting. Like if you want to kind of think about it, the south of that map is where you're sitting. So to your right, you're going to see the outbound area. That's where we're going to ship things out. You see the warehouse over there in the corner. We're going to do assembly. So we basically set up this place as a tiny factory, and we're going to try to run through a complete workflow, a complete shift in just a few minutes. Think about how the robots need to understand how the space is going to be used. You need to know those are racks, and the racks are not moving usually. Some areas, for example, may have traffic rules, so you may not want a traffic jam. If you're thinking about your fleet, your robots are everywhere. How do you keep track of them? Are they okay? Are they healthy? Do they have any incidents? So remember, robots are generating data all the time, and they need to be actively managed. But let's say I'm the plant manager here at McCormick, so I don't really care about all the other robots. And let's say I want to see how all my current vendors are working, and I don't care about offline robots. I'm going to use this also as a bit of a cheat sheet for me to remember all the vendors that are represented here. So I'm going to read from left to right. So Ati Motors is the yellow tug that you see over there. It's a workhorse. It can carry a lot of weight. It can go inside, indoors and outdoors. So let's say you have a plant and you have different buildings and you need to cross material from one to the other. So it has some unique capabilities. We have Kärcher is that cleaning machine over there, the gray one in the back. And, why do you want a cleaning machine? Well, you want to keep the environment healthy for people, and you also want to keep it clean for the robots. Robots also get tangled with debris. And if you've been to a warehouse, those places can get pretty dirty. Then next we have Neura, which is a company that makes this mobile manipulator over there. So as the name implies, the base moves, the top can manipulate, can pick and place, and it's very unique in that it can detach. So the base can leave the robot, the cobot in a stationary place and go do some other work. And then we have Quasi. So sometimes robots are really hefty like this one. Sometimes they're really lightweight. So this cart is actually a robot as well. And then, you know, it's 2026, so we need humanoid robots. So we have the Unitree G1. I wanted to highlight that you don't always have just robots. Typical operations, you're still going to have a lot of manual vehicles. You're still going to have people and robots collaborating. So we're going to put that pallet stacker behind me to work as well, but we're going to make it smart by using real-time location. These systems, they don't actually know about each other. They were designed for that specific purpose. What we're showing here is InOrbit Space Intelligence. That's our software that is going to act as the orchestrator. And I keep saying orchestration, so picture all of these robots as musicians or instruments. In an orchestra, you need percussion, you need wind, and you need a conductor. So we're going to try to create some harmony here over the next few minutes. When you put robots to work, there's usually something that knows what the work is. Warehouse execution system or warehouse management system in a warehouse. It might be an ERP in a facility. We work in hospitals, so there it might be an electronic medical record. There's always a system that knows what should be happening. Our job is to translate that into the physical world. So you're going from digital only to physical. And translation is actually, excuse me, a good way to describe it. We are able to speak with each robot in its own language, if you will. But there's some help on the way. So there's a new standard called ISO 21423. I call it 23 because those are that's a bit of a mouthful. So what 23 can do is it will make it easier for a fleet manager to talk to a robot through a standard protocol, but it adds something different. If you look around, a lot of these robots already come with a fleet manager. So why reinvent that? For example, a robot like Omron or Peer, which I didn't mention before, we're not using them in this particular demo, they come with their own fleet manager. So with 23, what you're able to do is have the orchestration layer, like InOrbit, speak with the fleet manager, and then the fleet manager can speak with the robot in whatever it wants in its native protocol. So that allows a lot more flexibility. It's something we've been calling federated orchestration, because we allow each fleet manager to manage its own robots, but it wouldn't make sense for, you know, Omron to manage Ati and conversely. I've selected the Quasi robot. I can get a lot of information about the robot, send commands to it. But I think the exciting part is how do we put all of these robots in a single map, right? So what you're seeing here, all the robots together, this robot over here, you see these avatars that represent. There's one that looks like a forklift, that's the stacker over there. So this is going to update in real time. And to show you, instead of sending the robot, I'm actually going to place an order in my WMS. And we're going to need a few parts. And remember, what we're trying to achieve here is a kind of a full shift in just a few minutes. All right, so here's what just happened. We just placed an order, and now that translation layer has to kick in, and it's going to start sending robots on their missions. And the first one is the lightweight cart. It's gonna head to the warehouse. Of course, this is just a cart, so it needs a little bit of help for picking the items. I'm gonna do some picking over here. So this is often called kitting in areas, so I'm placing some components that are going to be needed. Just say continue, and I can move on. And again, you can see here, we're seeing the robot moving. We're also seeing that kind of first-person view from the perspective of the robot. It's going on a milk run. Basically, it's going to stop at multiple stations, so people working there can pick up the items. The items themselves were selected by the warehouse management system. And of course, in a real factory, the distance between the warehouse and the assembly area might be, hundreds of yards. And this saves time to, go back and forth. It's not that I'm lazy and I don't want to walk all the way there, but it would be a waste of time to have someone just walking around. This one completed, and now we have the next robot already on its way. I think this is really great. Let's see. So you can see that as the robot is on its way, it's reporting its progress. So we have this notion of missions, and a mission can represent a sequence of steps. So in this case, this has to go dock in its dock, and then it's going to try to pick up that box and hand it over to Sean. So while this is going on, we talked to a lot of companies, and I think this idea of orchestration, maybe just 5 years ago, was like, well, do I really have that complexity? I think that has changed. We're seeing more and more robotics companies entering the space. We're now going to have humanoid robots also participating in the workforce. So I think the diversity of robots is growing, and the more diverse the types of robots you have, the more you are going to need this, some level of coordination. In this case, we're showing a kind of simplified case. Normally you would have many of each type of robot, not one of each kind like we have here. You're going to see more robots working at once. Here, we're trying to keep it simple given the space restrictions we have. All right, but let's get a little bit of help from a friend. And for this one, I'm going to try something a little different. G1, deliver parts. So some of you may have heard of something called agentic AI. So agentic AI means you express your intent and it figures out how to satisfy it. So in this case, the agentic AI layer figured out who we were talking about, what deliver means, and dispatch the robot. Then you have physical AI. Physical AI is what the robot is using to perceive the world, figure out how to act, and how to carry out commands. So these two are working together in this case. So you're really seeing kind of like at the forefront of robotics. All right. So looks like Sean is done with his assembly. He's getting ready to ship everything. Let's get shipping. So I'm going to switch now to the Sherpa robot. That's the Ati robot, the tug over there. And it's a heavier robot. It can collect a lot of items to be shipped out. So I'm actually going to send it on a mission. So in this case, the robot is following a predefined route. It knows where it needs to go because we send the command, and it's going to go to the outbound area. Now, there's a topic I want to talk about, which is really important, which is safety. So I'm standing in the robot's way, and the robot can see me and plan to go around me or at least not run into me. So I think it's doing a great job. I'm going to make its life a little bit easier, but this is using the onboard sensors, and you can see a LiDAR. Like if anyone has been on a Waymo, this is like a smaller version of a Waymo, and it can see as far as the sensors can go. So here you saw one version of how to manage an obstacle where it was following a route, but instead of just waiting, it can go around the obstacle and then resume the route. So this comes really handy when, some places are very structured, some places less so. So this gives you that adaptability. We're pretending that there's a truck there and we're loading things, right? So now I think the robot can continue and go out of its way. And remember, I talked about humans and robots working together. So it's almost impossible to get rid of forklifts, right? They're so valuable, so flexible. So even if you have a lot of robots, you're likely to have a lot of forklifts or stackers or carts. So what we're trying to do here is show how those can participate in the same orchestra, in the same operation. We have Sean here is going to pick up a box, and let me see if I can show it here. So you can see that as he is moving the stacker, it's updating on the map. But also the zones that are on the map are changing color. So think of it this way. We're like the eye in the sky that sees where everything is. The system is always responding to everything that's moving. It can react in real time to things that are happening. You can probably tell this is not Sean's day job, but he's doing a great job of picking the items. So now here's what's happening. He started a mission. So when I go over here, remember when the robot was going around, it was carrying out a mission. Now we can do the exact same thing with this. He didn't have to press any buttons. We just know you're picking over here and dropping over there. And sometimes, you need to pick a lot of pallets and you're going back and forth. So this is going to give you exact timing. It will figure out the path of every robot. And maybe this helps you, for example, run a more efficient operation. Even with manual vehicles, we can control robots, but we can't always control exactly what's happening. Let's assume this is the end of the shift. We want to leave things in a good state before we prepare for that. So we're going to do some cleanup. And once again, I'm walking around. I don't have time to be in front of my computer. So I'm going to talk to my cleaning robot. dispatch KB50 to clean area. By the way, while this is going, remember I talked about agentic AI? I'm using it to dispatch a mission. I can actually use it to define a mission. So I can say, I want a mission where the robot picks up over here, goes over there. You don't even need to know anything. You just say it in natural language, and then the system figures out how to interpret what you said and convert it into an actual mission. You can do the same with almost anything in our system. You can create a dashboard, say, I need a dashboard that allows me to track robots in a certain way. You don't have to design it. And of course, different people typically need to see the system in a different way, right? So if you're the plant manager, you want to see everything that's happening. If you're running the warehouse, you should focus on that. If you're in HQ, you want to see every plant. While this is going, we're getting a notification, we're getting a warning that Sean, I think he was maybe a little distracted, left the pallet stacker in the wrong place. And now we're trying to clean this, and we can't move it. But what we can do is we can send a notification to Sean to come and rescue the stacker, right? Of course, it's not autonomous, so we can't move it, but Sean and the stacker together can clear the space. Okay, so you see that zone is red where the stacker is. The other robot, we paused it at the edge to take its turn. As soon as we're clear, it can continue. So very smooth. This is good when you have a conflict. Even better is to not have it, right? I want to talk about what's next beyond what you're seeing here. Once you have all the data from every robot, every mission, every point where it spans, now you can create this view over time of like where everything goes. And now you can use that to run optimization. So what that means is you can use AI to figure out how to run your missions better tomorrow than you did today. Today maybe was not as or much better than yesterday. So this continuous improvement loop is now enabled through all of this. There's a lot of technology involved. There's simulation to understand. You want to gather data, which is what we're doing. Then you want to do what if, right? And then you let the AI loose, and it will create, a million what ifs. Pick the best one, and then because the simulation and the robots, or the system that tells the robots what to do are one and the same. They're not disparate systems. Now you get this like closed loop of optimization, which is what you really want to see. The way you train a robot like this is very easy. You just drive it around the perimeter of the area you want to clean, and then you say, fill it in. And if you're ice hockey fans, it will Zamboni the whole place. Let me show you one last thing, which is analytics. This was very kind of like in the day-to-day, but what you want to see is how are my robots performing? And sometimes what you want to be able to see, let's do the last 2 days, and compare vendors. So something like this is super helpful if you're in management. It allows you to figure out how are my different types of robots by my different vendors running. So even if you have, you may have an older robot that you bought 5 years ago, you buy a new one, you could have them run the exact same path, the same mission, but then you can say, okay, which one is better? Should I buy more of this, or brand A or brand B? Typically, it's very hard to do this kind of apples to apples comparison. So having a common framework gives you more than just, sharing the map. It's actually giving you a way to manage your operations. And I think with that, we're probably at time, perfect timing. happy to stay around for any questions you may have, and thank you for your attention.